On Explorations this time, how a debilitating brain disease may have inspired these stunning works of art. This is Explorations, unlocking the mysteries of the most complex creation in the universe, ourselves. We have lost one of our most amazing abilities. Up to the age of 6 months, babies are able to swim comfortably underwater, thanks to a reflex that still puzzles scientists. A muscle in their throats seals their lungs, allowing any water taken in through the mouth to be passed harmlessly into the stomach. Is this a leftover ability from the womb, or a legacy of evolution from our aquatic past? We lose this reflex very quickly as we develop, but some people have found a way to activate another diving reflex. The most successful freedivers can train their bodies to hold their breath for up to 6 minutes. The body's need to breathe is so fundamental. By holding our breath, we are suppressing our strongest instinct, as this diver is doing.
Most of us actually feel uncomfortable if we don't breathe, purely because our brain says, look, breathe. Now, if you hold your breath longer than that, then carbon dioxide builds up in your body, and that too makes you want to breathe. If you immerse your head in water, you can't breathe. That means the oxygen that you have in your body is very precious. And there's only 2 places you want it to go, really, your heart and your brain. So they just shut down the rest of the circulation and stop pumping blood around the body where they don't need it.
Free divers can plunge to unimaginable depths because they use their minds to control and overrule their bodies.
If you train and if you dive only with your muscles, with your body, you can just reach your maximal depth, your natural gift, but you cannot go over. If you want to go over, you have to dive with your head, mentally. That's the secret, I think, and that's free diving.
So could we all do it? The biggest hurdle is pressure. As freedivers plunge further down, all the air spaces in their bodies are compressed. The lungs are crushed to 1/7 of their normal size. To survive, we need to equalize external pressures with those inside our body. This has been done by pumping air into ourselves. Now, experiments are being done to see if we can breathe liquids whilst underwater. Perfluorocarbons carry 25 times more oxygen than water and deliver it to the lungs 3 times more effectively than air. Already, mice have survived in the liquid for several weeks. They make a complete recovery in the air once the liquid has drained away from their lungs. With this technology, divers could plunge hundreds of meters below water and stay there for up to an hour on 1 lungful of liquid air.